Hey everyone, this is 8.7 on polar equations and graphs. So we're going to look at a different type of coordinate system. You know, the rectangular system, x, y, axes, all that. This is an alternate form. It's called the polar coordinate system, and it uses some trigonometry. But when you think about it, just think about it as another way to describe a point in a plane. And to do that, you can look at that picture below, down over here, this picture. Notice it has r theta, where r is the distance out to that point from the origin, and theta is the angle made with the positive axis. So all of that really just describes that. So I would just jump right into some examples, and that's probably the best way to check this out. What if we want to do 345? So if I want to plot that point, what I'm going to do is find the angle 45 degrees and then go 3 units out. So this is polar graph paper where each circle is a unit of 1, right? So the innermost circle has a radius of 1, and then radius of 2, radius of 3, etc. So you're going to find that third circle out, right? So if I zoom in on this at the 45-degree angle, I'm going to find it here, right? So there's 1, 2, 3 circles out, okay? And then I plot that point on the 45-degree line. That's the point 345. So that would be the point A right there. All right, so that's the idea. Oops, reversed everything. How about point B? 2, 2 pi over 3. Okay, so the angle could be in radians or degrees. If it's in radians, you can convert it to degrees if it helps. This polar graph paper is all in degrees, labeled in degrees. So 2 pi over 3 is 120 degrees. And I'm going to go 2 units out on that circle. So that would be this point right there. That would be point B. Okay. C is 4 180. So at the 180 mark, go 1, 2, 3, 4 circles out. And there's point C. And then we get to D where we have a negative R. So what does it say about a negative R? That's right here, this bullet point. If R is less than 0, then the point P lies on the ray pointing in the opposite direction of the terminal side of theta, in a distance of R from the pole. Okay, so you have to go 180 degrees in the opposite direction on those. So for point D, it's 60 degrees. So we're going to go and just add 180 to that, which is 240. So we're going to go 2 units in the 240 direction. And so we're on that 240 line on that second circle. And that would be point D. Okay, so that's how the negative works. Negative R. Now E has a negative angle. We know how to handle that. That just means you go clockwise on the circle. So negative 30 degrees is the same location as 330. So on the 330 line, let's zoom in a little on that one. That's right there. That would be the point E, the first circle at the 330. Okay. How about 3, 0? So that's 3 is the R and 0 is the angle, right? So I'm going to go towards the angle 0, the third circle out. That's point F. G is negative 3, 0. Okay, so the angle is 0, but it's a negative R, so you have to go 180 degrees in the opposite direction of 0, which would be 180, and then the third circle out, which would be right there. So that would be G. How about 0, 5 pi over 4? Well, if R is 0, that's just the origin. It doesn't matter what the angle is. You're not going anywhere because the R is 0. And then how about negative 5 pi over 2? So pi over 2 is the same as 90 degrees. So go 180 degrees in the opposite direction from 90, which will be 270. Or you can always just add 180. 90 plus 180 is 270, and go 5 units in that direction. The 5th circle out, be there. Okay, so there's a little tutorial on how to plot points using this new polar coordinate system. What's next? Okay. Can you give 2 other pairs of polar coordinates for each of those points? Now, unlike rectangular coordinate system, polar coordinates are not unique. There's lots of polar coordinates for the same point. Right? So for example, that point right here, when A is 345, you could also call that, well, if you added 180 to 45, you would get 225, and then change that to a -3, right? So -3, 225 would also be in that very same location as point A. -3, 225, you see that? Because that means go 180 degrees in the opposite direction of 225, because it's a -3. So that would put you at 45 degrees. It wants 2, so how about another one? Well, you can always do coterminal angles. So if we stick with the +3, but then added 360 to 45, I go 1 full revolution. So 45 plus 360 is 405. These will be alternate forms for A. Okay, so if you have a question then that asks you for alternate forms, some techniques we're using here. That first point, add 180 and change the R to a negative. Or the second point, keep the R positive, add 360 to the angle, right? And so we can do that with all of these. Okay, so how about B? Angle B was 2 pi over 3. You could leave it radians, or you can go to 120. Remember, 2 pi over 3 is the same as 120. So we can do -2 and then add 180 to 120, right? So that would be one alternative point. -2, 300. 120 plus 180 is 300. Or we can keep it +2 and add 360 to 120, 1 full revolution. 360 plus 120, 480. Right. And then finally C. C was, what was it? 4 180. So my little techniques here, that is a letter C. I could change it to a -4 and add 180, which would be 360 degrees. Right? Or 0, I guess, would also work. Right? Or keep it +4 and add 360 to 180, which is 540. Okay, so that takes care of that. And these are just a few. There are an infinite number of possible answers for these. Okay, so I just gave some techniques, but we could keep on going. Just keep on adding 360 and you'll get a new angle in the same location as that point. Okay, here are some formulas that relate polar coordinates to rectangular coordinates, which look like what we did with vectors and what we did with complex numbers. So it's kind of the same game. So these will be useful if you want to convert a polar coordinate to rectangular or vice versa. So for number 3 down here, convert those points A, B, C to rectangular form. Okay, so for that, if you're going from polar to rectangular, use those top 2. Because if you have polar, you know the R and the theta, and you want to find the X and the Y to convert it to rectangular. Okay, so for point A, we had R was 3 and theta 45. So we can plug it into those formulas. So x is going to be r cosine theta, 3 cosine 45. And then y is 3 sine 45. And then now use your unit circle knowledge. Cosine of 45 is √2/2. So this is 3 √2/2 for the x. And the sine is actually the same at 45 degrees. So the polar coordinate, the rectangular form is x comma y. 3 √2/2, comma 3 √2/2. All right. That's the same point, just described in a different way using x and y, horizontal and vertical, as opposed to the angle and the distance from the origin. Okay, so we can do B as well. That was A. The point B, and again, I'm just going to stick with degrees. So B is 2, so the R is 2. So X is going to be 2 cosine 120. Y is equal to 2 sine 120. And then the cosine of 120 is -1/2 from unit circle. And it's positive √3/2 for the sine. So that's -1 and √3. My point will be -1, comma, √3. For C, same old thing. C was 4 comma 180. So X is 4 cosine 180, which is 4 times -1 from the unit circle, -4. And then Y is equal to 4 sine 180. The sine of 180 is 0. So that's 0. So this point will be -4 comma 0x comma y, which seems to be right. That one's visually correct, right? Point C, remember where that was, right there. That's -4 comma 0 from our old standard xy, right? -4 on the x-axis, 0 on the y. Okay. How about the other way? What if we have a rectangular point and you want to find polar coordinates? Then use those bottom two. Those will come in handy for that direction. So for the rectangular, 0.5 comma -5, remember that's xy for rectangular. So that's your x, that's the y. And we need to find r and theta. So I would get r first by that formula above. R is the square root of x squared plus y squared, 5 squared plus -5 squared, which is the square root of 25 plus 25, 50, which reduces to 5 √2, right? Because 50 is 25 times 2, square root of 25 is 5. So 5 √2. And then I need the angle. And this is the one where you're going to have to be kind of careful with that tangent formula. Get the reference angle first and then figure out which quadrant you're in. So I'm going to do tangent theta prime and do y over x, but ignore negatives because I'm just after that reference angle. Right? So that's y over x without negatives. And then I'm going to get my answer. Theta prime is going to be tangent inverse of 5/5, which equals 1, which is 45 degrees. So that's a 45-degree reference angle. Now, which quadrant am I in for this point? Well, x positive, y negative, that would put you in quadrant 4. So in quadrant 4, to get my angle, I would do 360 minus 45. And that's 315. That's a quadrant 4 angle. So my final point is 5 √2 r comma theta. Okay. Now it asks for 2 pairs, so it wants another one. So what else could we do there? Well, I could do my little trick of changing the r to a negative and then subtracting or adding 180 degrees to the 315. So let's just subtract to make it smaller. And oh yeah, it does want between 0 and 360. So let's subtract 180. If I subtract 180, I get 135. And there's another point. That's the same point. So, different values. Okay, let's keep on going here. For this point, this one, let's start with my r. Calculate that out. That's going to be the square root of 9, which is 3. And then I can sort of just figure out what the angle is because I know where that point is, right? 0, -3 is here. That angle, 270 degrees. Okay, so this point is 3, 270. If I want another point, I could do -3 and then subtract off a 180. That's 90. Okay. Finally, on this page, for each, let's give the equivalent polar equation and sketch the graph. Okay, so again, you can use those formulas above. Let's get the equation first, and then we'll try to sketch it. So x, what would x equal? Well, above, look at that formula. X equals r cosine theta. So my goal here is to get rid of x's and y's and replace it with r's and thetas. And then y is r sine theta. And then equals 5. Okay, and then typically the way polar equations look, you solve them for r. That's the standard form. So I'm going to try to solve this for r. And the way to do that is first factor out that common r. So I'm going to take an r out of both of these, and I'm left with 2 cosine theta minus sine theta. Right? And then divide that entire thing in parentheses, and you have your final answer. So that's the polar form of that equation. And remember with that, if I graph it, remember what that is? That's a line, right? That's y equals 2x minus 5. If I solve for y, right? So that's a little review of basic algebra. Y-intercept of 5, slope of 2, right? Get a quick rough sketch of that. But if you try to graph it with this polar form, which might be a little more complicated, you would get that same line. Right? Plugging in thetas and getting r's. Okay, one more, and then we'll move on to something else. Here again, I'm going to replace x with r cosine theta and y with r sine theta, but then each one is squared. So that gets rid of x's and y's and replaces with r's and thetas. Now I'm going to try to get this to where r is by itself. So I'm going to do algebraically square this out. That's r squared cosine squared. That's r squared sine squared. Now factor out the r squared. And notice what you get. You get cosine squared plus sine squared is 1. Replace that with 1. So this is r squared equals 9, which actually gives you 2 possible. Well, you could probably just leave it like that, or you can write it r equals plus or minus 3. You would need both of those. You could leave it like that too. And if you remember what that is, that's a circle of radius 3. So there's my, missed it. There's my rough sketch. Circle of radius 3. Okay, that's it for now. I'll continue in the next video. Send questions my way if you have any. Hope all is well out there. Bye.